Master Day. This is Aisha.
Hi, it's Christina.
And we're going to explain the energy flow diagram for our mousetrap car.
Yeah, okay. Okay, so basically, this is the first step before we do anything to the spring, meaning it's, nothing's going on, which is why everything is 0. So, yeah, since we haven't pulled it or we haven't exerted any force on it, that's why it's all 0. Since we know that the spring is going in with 0 everything, then we know that when it comes out, it should also be equivalent to 0, since the energy of the force is kind of like the same. It's gonna be the same throughout the system, so it's not gonna change. Yeah.
And then also, because in the beginning we don't pull the spring, so EL is 0, and then in the end, after we've pulled the spring, B stands for like after the spring already goes, like when the spring goes back, so that's why EL is 0 again.
It's like a constant again.
Yeah, so that's why both ELs are 0 before and after. And then EK, the cars aren't going to be moving at part A or at part B, because at part A we haven't pulled the spring yet, and at part B, it's already been pulled and the cars come to a stop. And so that way we know that work went in and E dis came out. So we have plus W minus E dis. So we have 0 is equal to W minus ES, which equals to 0. So then with that, we know that work equals to E dis, which is our general equation. And then in the previous screencast, we found that the total energy was about 1.324 joules. So with that said, we know that our work has to be 1.324 joules, and because energy is conserved, then we also know that the E dis has to be all the same, 1.324 joules, because
so that's what it was prior. So.
Yeah, exactly. So we know that there was a force of 1.32 joules exerted on, and then also the same amount of energy left. So yeah, that's our energy flow diagram.